Good afternoon.
Now listen, there is a lot to get through, but we can do this in a timely fashion. 6.5 is graphing square root and cube root functions. Here's the deal. When you graph things like quadratic stuff that we graph, what did that h and k do on my quadratic formulas? Yeah, what did it do to the vertex? So my vertex on a parabola, right, is 0, 0. But if I have an h and a k in there, it does. It shifts it like to the left and right or up and down, right? Or both. The h goes with my x, the k goes with my y. Also remember when we did that the h is always opposite of what it shows. So if it was negative, it was actually a positive shift. And when it was positive, it was actually a negative shift. But the k is always true to what it is. Same thing is going to apply when we have a square root and a cube root. Okay? The h and k, instead of my square root starting here at 0, 0, the h and k is going to shift it. Instead of my turning point being 0, 0 on a cube root, the h and k is going to shift it. Okay? The a in front, what did the a in front tell me? Yeah. If it shrinks or stretches and if it flips. Okay? Because if it's negative, it flips. Okay? Now, the domain of a parent function of a square root is domain is x is greater than or equal to 0. My range is y is greater than or equal to 0. On a cubic function, I told you last week, the domain and range are always what? All real numbers. Okay? Do not miss that on your quiz tomorrow.
I'll try. Repeat.
Domain and range on cubic functions are always all real numbers. Because it's continuing forever in both directions. Okay, so now we're going to start graphing things and comparing it to the parent function. Okay? And we're going to compare it in both words and on a graph. So you might want to use two colors on your homework. You don't have to, you can. Whatever floats your boat. Okay, let's talk about how we graph some of this stuff. And then we'll talk about domain and range. If I want to graph, let's start with the parent function. Y equals radical x. What does that mean? Where's the starting point? 0, 0. If I plug in a 1, what do I get out?
1.
And if I plug in a 4, what do I get out?
2.
A 2. A 2. The square root of 4 is 2. Okay, so I just pick easy numbers. On all of your assignments tonight, I would suggest you just pick things that have a perfect square and perfect cube roots. Okay, pick easy numbers. When I do square roots, remember I don't have to plug in any negatives because I can't have a negative inside of my square. Okay, that's the parent function. Now, let's talk about this. If it has this half in front of it, what does that mean is going to happen to this graph? No, there's no negative. It's going to do what? You think it's going to shrink? Okay, so let's look and see. Okay, so once again, I'm just going to plug in 0, 1, and 4 because I know that those are perfect squares. If I plug in 0, 1, and 4, okay, if I plug a 0 in here, what do I get out? 0. 0, because the square root of 0 is 0. 0 times a half is 0. So my starting point is not changing on this one. And that makes sense because there's nothing in here being added or subtracted. It's the x. And there's nothing on the outside being added or subtracted. So my starting point didn't change. When I plug a 1 in, square root of 1 is
1.
And 1 times a half is? So I plug 1 and a half. Okay? Square root of 4 is?
2.
And 2 times a half is?
1.
So I have 4, 1. So what happened to this graph? What happened to that graph? It was, well, no.
It just got shorter.
It got shorter, okay? It got shorter, so that's called shrinking. Remember, short and fat, tall and skinny. That's how we're going to remember it, even though that's not really true in life. But it's easier to think of it that way, right? When I squish something down, it gets short and fat. So I'm squishing it down because I multiplied by a fraction. If I multiply by a whole number, I'm going to stretch it. So this shrunk by a unit of what? Of a half, okay? So when I say that, now, Is it a horizontal or a vertical shrink? Good. So, a half vertical shrink. So now I have my graphs compared. I have a description of what's happening, and now I need the domain and the range. Here's how you figure out the domain and range. Go to the starting point, okay? The domain and range will always come from the x and y of your starting point. What is the x of my starting point here?
0.
So what does my domain have to be if my graph is going this way? Greater than or equal to 0. X is greater than or equal to 0. What's my y?
0.
So my range is,
Y is greater or equal to 0.
yeah, y is greater than or equal to 0. That's how I can find domain and range, okay, on square root functions. Does that make sense? Go to your starting point, and then your x is your domain, your y is your range, okay?
You only have to go up to like 4.
Do you have to what?
Like, how far do you have to go up like to graph? Because you only went up to like 4.
Yeah, I only graphed like 3 numbers. That's all I'm gonna graph probably. Okay? Because later on we're gonna graph and we're gonna shift, and so it's gonna take more time, so we're just gonna plug in some numbers. Here I have a cube root function. Cube root, okay? Means I wanna plug in numbers that I know have perfect cubes, like 1 and 8. But when you have cube root, do you plug only positives in?
No.
No, you have to also plug in negatives, okay? So on these, you're going to spend a little bit more time because you have to plug in on both sides. Got it? Okay. So let's talk about that. I'm going to go ahead and let's graph this parent function again. If I graph y, the cube root of x, where's my turning point? 0, 0. Okay, great. Now let's plug in. If I plug in a 1, what do I get out? 1. If I plug in -1, what do I get out? If I plug in 8, what do I get out?
2.
Okay, 2, 4, 6, 8. And if I plug in -8, I get 2, 4, 6, 8. Okay, so my parent function looks something along this range. Yes?
Yes.
Okay. Now, what's going to happen here with that -3 in front?
It's gonna flip.
It's going to flip and it's going to stretch. So I'm going to say that it flips and has what type of stretch? Mm-hmm. You're right though too, I have to say it that way. Stretch of 3, right? Okay, so now when I plug in I'm going to plug in a -8, a -1, a 0, a 1, and an 8, okay, because I choose easy numbers. When I plug in a -8, I get a -2 out, right? And then I have -2 times -3. 6. When I put in a -1, I get a -1 out, and I have a -1 times -3. When I plug in a 0, I get a 0 out. So is my turning point changing at all? No. Okay, my turning point's going to be right here. When I plug in a 1, what am I going to get out? -3. And when I plug in an 8, what am I going to get out? Good. So I plug in -1, I get +3. I plug in -8, 2, 4, 6, 8. I get 6. I plug in 1. I get -3. I plug in 2, 4, 6, and I get, or 8, and I get -6. So my graph looks like this. Okay? And now, the only thing I have to answer is domain and range. Yep. All real numbers for both. And you can write ARN. Okay? So, that is pretty simple right there, yeah?
Yeah.
Okay, now let's talk about when my H and K are different. Okay? So if my H and K are different, here's what you're going to do. You're going to sketch the graph of just this portion, the A and the cube root of x, or the A and the square root of x. And from there, I'm then going to shift each point I graphed. Because if you try to plug points in and graph them, it's gonna become more confusing in the long run when we get bigger problems. Okay, so if you do it this way, especially if some of you are gonna go to pre-calc or anything like that, if you do it this way, it becomes easier for sine, cosine, and tangent graphs as well, okay? And this is how Mr. Rice teaches it in pre-calc and everything, so we're gonna practice it that way. Okay? So if I have y equals -2, x minus 3 plus 2, okay? I'm going to start, it says state the domain and range, so I'll state that after I get done. But let us start by graphing it this way. Okay, so let us do this. Let's focus on just this portion, y equals -2 radical x, okay? That's easy to graph. Now, let's plug in, do I plug in negative numbers to this one? No, so let's plug in 0, 1, and 4 again. Make it easy, okay? If I plug in a 0, and 1, and 4, when I plug in 0, what do you get out?
0.
Okay, when I plug in 1, what do I get out?
-2.
And when I plug in 4, what do I get out?
-4.
Okay, so when I graph those, I have this, I have 1, -2, and I have 4, -4, right?
Yeah.
Okay, so the graph would look like this, correct? Now, what is my h and my k? Okay, h is not -3, it is +3, and my k is 2. Now I'm going to take each of these points and I'm going to go over 3, up 2. So from here, because h is my x, right? I'm going to shift this point 1, 2, 3, and up 2. That's where the starting of this graph is. I'm going to shift this point 1, 2, 3, up 2. I'm going to shift this point 1, 2, 3, and then I go up 2 to -2, right? Here is the graph of that function. All I did was shift the points. Okay, that shouldn't be hard. That should be pretty easy. We graph the easy one and then we shift. Now, domain and range. Where's the starting point?
0, 0.
No.
It's 3, 2.
Okay, so what's my domain?
Anything x
Uh-huh.
greater than or equal to 3.
Yep, x is greater than or equal to 3. What's my range?
Y is greater or equal than 2.
No.
2.
No. What is happening with this graph? It's not rising, it's falling.
Less than.
Yes. So y is less than or equal to 2. My domain and range come from this point right here, 3, 2, because it's the starting point. My x, my y. And then you have to use common sense. If it's going down, it's less than. If it's going up, it's greater than. Okay? Can you handle graphing that way?
Yeah.
It's not hard, okay? It's pretty simple. My suggestion to you is always plug in 0, 1, and 4 on the square root function. It's all you need to plug in. Let's look at a cubic function. And this is your last one. On a cubic function, okay, I'm going to always plug in -8, -1, 0, 1, and 8, because it's just easy, okay? Okay, so let us focus on y equals 3, the cube root of x. That's what we want to graph first, okay? So we want to graph y equals 3, the cube root of x, which means from the parent function, it's going to stretch at 3 units, okay? When I plug in -8, -1, 0, 1, and 8, okay? When I plug 0 in, I'm going to get 0. That's easy, so I'm just going to start there. When I plug -8 in, the cube root of -8 is, and -2 times 3 is,
6.
good. When I plug in -1, the cube root of -1 is, times 3, and then these should be opposite of it, right? This should be 3 and this should be 6. 2, 4, 6, 8, and I'm going up 6 2, 4, 5, I'm gonna need to make another line there. 6, okay. 1 is at 3, right? 0, 0. Negative 1's at negative 3. And 2, 4, 6, 8. And we're gonna go down here. Remember, yours will look nice because it's on graph paper. So this is what we got going on, right? Pretend that's perfect. Now, what's my H and my K?
-4 and 1.
Good, -4 and
Oh, negative
1. So each point is going to the left 4 and down 1. So this point, I'm going to start at my center, is going 1, 2, 3, 4, and down 1. This point goes over 4 and down 1. I ran out of board room. Okay. This point goes 1, 2, 3, 4, and down 1. Okay. This point goes 4 over and down 1. So 1, 2, 3, 4, down 1. And this point is also going over 4 and down 1. So if this is here, it's going 1, 2, 3, 4, and it's going to here, right? To here. Okay. So that went over 4 and down 1. So this is my turning point, right? Here's the way this graph goes. And then this one comes through here, and it would be like over there someplace, right? Okay, so I re-graphed that. On your homework, clearly you can erase those over lines, or you can count because they're squares and it makes it easier. Domain, range, okay? What's domain and range? No,
really?
cubic, it's cubic, okay? That is what you're doing tonight. You're graphing those. That's why I said you can do this on your quiz tomorrow. Use the same numbers all the time. It makes it easy.